To our very last question before the diploma question. So it says, well, it doesn't say it, I guess. I want to determine the exact value of this angle. So tan 5 pi over 12. So if we go into our formula sheet, or sorry, unit circle, you'll find again, we don't know what 5 pi over 12 is. We don't have the exact value for it. So we need to break this apart into things that we know, so some angles we know. So how I kind of thought about this is we have tan, and I'm going to break this up into 2 pi over 12 plus 3 pi over 12 and see, hey, are those on the unit circle? Well, they're not simplified yet. So let's simplify these and see if they actually exist, or ones that we know. So 2 divided by 12, yeah, you get pi over 6. That's on the unit circle. And then we get pi over 4. So that's also on the unit circle. So we can actually do something with this then. If it didn't work, you would have to try different numbers. So possibly you could try 1 pi plus 4 pi and just try some different combinations. There's not actually that many that exist. All right then. So now we have an identity. We have an addition for a tangent, so I have two angles. So from the formula sheet, then I'm going to go tan angle A, pi over 6, plus tan angle B, which is pi over 4, all over 1 minus tan angle A. We're going to have to figure out how to change this. So pi over 6, and then tan pi over 4. And that's just from the formula sheet again. Now we can start actually evaluating this. So tan pi over 6 is equal to 1 over square root of 3. And we're adding tan pi over 4, which is just 1. Now on the denominator, we have 1 minus. So tan pi over 6, we already said was 1 over square root of 3, which is kind of ugly to have a complex fraction there. And then tan pi over 4, again, is just 1. Okay, so now we're getting somewhere. Now, how many steps you have to do in here depends on each person. When I'm looking at this denominator, so I'm just going to do some little side work here. 1, well, I need to have as a denominator of square root of 3. So really, that's the same as having square root of 3 over square root of 3. So that's going to save me some time right there. Why that's important is I can actually then add this 1 value, plus it's really going to be square root of 3 over square root of 3. So that's going to just save me a little bit of work right now to look at. We're going to leave the denominator. We can do the same thing for this 1 here as well. That 1 is actually square root of 3 over square root of 3. And why that's important is, once again, we do have this denominator square root of 3 here. So this is definitely a tougher question. So I have 1 plus square root of 3 all over square root of 3. Now that's just my numerator. All I've done, I'll do this in a different color, again, is added this 1 plus the square root. For my denominator, I'm going to go, I know that, I'm doing a different color, I know that 1 square root of 3 times 1 is just 1 over square root of 3. I'm not going to worry about that too much. But I do have this in a common denominator, so I get square root of 3 minus 1. So we get square root of 3 minus 1 all over square root of 3. Now you're going to get a complex fraction here. Again, I'm having some problems running out of space. So I'm going to kind of just deal with this in one step. Again, if you're not sure how to deal with complex fractions, leave a comment and we can just send you a quick video to remind yourself. So this is actually going to become, though, 1 plus square root of 3 all over square root of 3 minus 1. Now, unfortunately, we're not done. The square root of 3 has a radical in the denominator, so now I need to multiply by a conjugate. So again, the conjugate is going to take, it's going to be plus 1 instead. So square root of 3 plus 1. What I do to the denominator, I do to the numerator. Now, once again, we actually have a difference of, so we have a perfect square in the numerator, which is kind of nice, and we also have a difference of squares in the denominator. So I'm going to use some of those little tricks to kind of speed this up. So I know it's going to be square root of 3 times square root of 3, which is just 3. 1 times 1 is 1. And then we're going to have that middle term. So because it's a perfect square, it is going to be the square root of 3 doubled. So 2 times square root of 3. Now in the denominator, we have a difference of squares. So square root of 3 times square root of 3 is 3. The middle term is not going to exist. It's going to cancel itself out. So we're not going to worry about it. So negative 1 times positive 1 is minus 1. Finally, our last step, 3 plus 1 is 4. We get plus 2 square root of 3. And then 3 minus 1 is 2. Now we're so close to being done. If you remember from 20-1, you can see that the 4, the 2, and the 2, they all have a common multiple, or common factor, sorry, of 2, so we can divide everything by 2. And my final answer, I'm going to write in the top left corner here. So we end up actually with 4 divided by 2 is 2, plus 2 divided by 2 is 1, so we end up just with 2 plus square root 3. I'll write that again in the smaller writing. So just one more time, it becomes 2 plus square root 3. So actually, not a bad little number. Quite a bit of work, though, because of the rationalizing. Okay, moving on to our last question. This is a diploma question. I really like this one. It looks very difficult, but it simplifies so nicely. So the expression sine pi over 2 minus theta plus pi over 2 plus theta is equivalent to the expression. So we've got 4 expressions here. They look fairly similar. So this is not a time to guess and check. I would do the work separately and then match my questions. So what I'm looking at, I see I have sine, and then I have a minus, and then I have cosine, and I have an addition. So I have a subtraction identity and a addition identity. So for the sine part, I'll do that in red. So we're going to get sine pi over 2 times cosine theta plus cosine pi over 2 and then sine theta. Now that's just that one identity. That's it. Now for the second one, I'll do it in blue. So we're going to look at cosine. For cosine, we're going to have cos pi over 2. So, and this is an addition between these. So we're going to have cosine pi over 2 times cosine theta. And then now dealing with the second part, you're going to get minus sine pi over 2. No, so close. Times sine theta. Now this, it might look like, well, how can this possibly simplify to one of these 4? Well, the nice thing is when we go to evaluate, so sine pi over 2, well, that's actually just, that's just 1. So this right here, sine pi over 2 just becomes 1. So we actually are just left with cos theta. Now, alternatively, cosine pi over 2, well, that's actually equal to 0. So we don't have to worry about that term then. That term is actually gone. And then, again, we have cos pi over 2. Well, that's equal to 0. So anything times 0 is 0. That one is gone as well. Now, over here, sine pi over 2, that's equal to 1. So that's just going to be 1 times sine theta, which is just going to be, now we have to be a little bit careful with our signs here. There was a minus here. Looks like there was a minus there. Double check. Yeah, there was a minus there. So then I'm going to have minus sine theta. And so this question that looks quite difficult has some really nice cancellation. And so you're going to get cos theta minus sine theta, which is C. All right, thank you guys.